I'm grateful to be here to speak with you this morning. I've worked at Caterpillar for over 15 years in the marine and oil and gas business and various engineering and marketing sales roles. My current position here is technical sales support for the offshore business, along with our product development for products that are featured towards offshore applications. So again, I'm here to talk today to you about offshore products that meet emission standards and safety regulations that are out there. So products to meet your needs of the future. So first, we'll touch on some products and technology that we're developing to meet lower emissions. Also then we'll blend into not only meeting lower emissions, but utilizing natural gas. And then finally we'll wrap up with discussing products to address some safety concerns. So products that will then be classified towards ATEX or some NEC classifications. So before we start, I just want to touch base on the complete Caterpillar offshore product line of reciprocating engines. So we have products anywhere from 20 kilowatts up to 15 megawatts and growing on the reciprocating engine line. So towards the left-hand side of the screen here, these engines mainly run on distillate fuels. As you move up and towards the right, over towards the right, these engines can burn not only distillate fuels, but heavy fuels and natural gas. Caterpillar is constantly investing in research and development to improve power density, efficiencies for these products. And then as we're going to discuss today, a lot of that research and development is going into reducing emissions, utilizing natural gas, and providing safety features. So the first technology I want to discuss with you is called selective catalytic reduction, commonly known as SCR. This technology has been around for decades. It was actually patented back in 1957. It's gone through many changes over time. It's commonly used in road applications, on-road applications for lorries and trucks and on-highway vehicles. It has now been used offshore and other on-land applications. So we're going to discuss this technology, walk you through kind of the basic concept of this technology here in the next few slides. So how does SCR work? Okay, so SCR works, it's the process of which oxides of nitrogen, which is commonly known as NOx or NOx, which is contained in the diesel exhaust, are reduced to nitrogen and water. Okay, so it goes through a process where a diesel exhaust fluid, or known as DEF, which is nowadays a urea-based substance, is injected into the exhaust stream, and this can be injected utilizing an air assist technology or an airless injection into the exhaust stream. When it injects into and mixes with the exhaust gas, it then it flows through a catalyst. This chemical reaction then eliminates the NOx and turns the exhaust stream into nitrogen and water. So the advantages of a catalytic reduction system are that it's very highly efficient. I mean, you can reduce NOx levels by over 95%. And it can be turned on and off. So this is particularly an advantage in the offshore and marine mobile applications. So as you transient in and out of emission control areas, you can turn this technology on and off. The engine also can be optimized for optimal fuel economy. So the engine itself can produce a high level of NOx. By doing that your engine actually runs more efficiently, and then use the selective catalytic reduction system to then bring that NOx level down to meet a very stringent emissions requirements. And again, this is a proven emission solution. It's been around for over 50 years, and it's been constantly refined. But again, it's rather new to the offshore business. So this is something that, again, it's new. People are a little bit unfamiliar with it. They're a little bit nervous with everything that's new in the industry. So the other thing is this is all off engine. Okay, so this is after treatment. So the engine itself stays practically the same. Okay, we utilize the same engine that's been proven for durability and reliability. So not a whole lot changes to the engine itself. We just add on after treatment afterwards. All right, and there's no additional equipment that's required to meet some of the Tier 4 levels that are in the U.S. and some of the IMO levels and Euro levels that are in other parts of the world. So this selective catalytic reduction can be used, especially for offshore, without the need of a diesel oxidation catalyst or diesel particulate filter and some of these other type of after treatment systems that require a high level of maintenance and complex controls afterwards to function properly. So here's a general schematic of how the SCR system would be outlined on a offshore vessel or a rig. You'd have a urea tank, so you're going to have to, so this is new, you'd have to have some type of holding tank for urea systems, and you'd transfer that urea system, generally using a transfer pump, over to what we'll call a dosing cabinet. Now this dosing cabinet is actually houses the controls that will meter the amount of urea that goes into the exhaust stream depending upon the electronic feedback that it's getting from the engine to know, what loads the engine is running at. So how much do I have to meter that urea into the system? It will also receive information back from the exhaust stream after it goes through your clean emissions module to monitor how the emissions are functioning properly. So it will correct itself to make sure that emissions levels are maintained. And again, sometimes air compressors are needed to supply that air assist. Now this is generally used in much larger engines. So as you get to over a couple megawatts of power, you'll generally have some type of air assisting mechanism. And what that does is it breaks that urea down into a nice fine mist. So the mixture in the exhaust stream, it gets nice and mixed up prior to it entering into the catalyst. So here's an installation on board an offshore drilling rig. So you can see that the module will fit generally right over the diesel power generator, and sometimes it will fit further up in the exhaust stream itself. So we know that current designs for offshore rigs don't necessarily have a whole lot of room for extra equipment on board. Okay, so we're very cognizant of that fact. We've done some development work within the engine to minimize that module. So we know there's two things really that you need to do is minimize the size and minimize the cost of that module, and while at the same time providing ultimate operational cost to our customer, our optimized operational cost to our customers. All right, so again, here's a view of the installation in a rig. All right, so from there I'll move from the technology that not only reduces emissions but utilizes natural gas. All right, and the name of this technology is dual fuel. Okay, so dual fuel is a technology that utilizes a natural gas or liquid. So you have a liquid mode, and these can burn light fuels or heavy fuels, and then a gas mode, which will burn natural gas, so compressed gas, CNG, or LNG type of gas, and it will utilize a pilot, a liquid pilot, commonly marine diesel oil, to be used as a pilot to ignite the natural gas. Now this technology at Caterpillar is generally used in products about 3 megawatts and higher. So the technology I'll describe today really pertains to the higher power engines that Caterpillar produces. So how does dual fuel work? So dual fuel, again, you have a gas mode and a liquid mode, we'll call it. You can run on a gas mode from up to about 90% to 99% of gas. And again, that 1% is used for a pilot fuel. And so then, therefore, when you're running in gas mode, you're generally between 1 and 10% of your utilizing liquid fuel. The changeover, again, can go from a liquid mode to a gas mode, and that's generally possible when you're operating your engine about 20 to 80% load. So when you're operating at that load, you can then put yourself from liquid mode into a gas mode. And that'll take approximately a minute to have that to change over. And it does vary sometimes on the natural gas that is flowing into the engine. But in general, it takes approximately 1 minute. Now, when you're in gas mode and you want to go back to a liquid mode, okay, this can be done manually. So you can walk right up at your operating station and press a button and switch back to gas mode. Or it can be done automatically. So the engine itself senses that there's some issues with the natural gas supply to your engine, and it will switch it back automatically to a liquid mode. And this can be done. This is done in about a second. So this switch over from gas to liquid mode goes back to in about a second, and you maintain that power. So you never really see any blips or anything in your power output of your engine. Now, what are the advantages of dual fuel? Well, the first advantage is it provides you an operational flexibility. So in general, you can burn a light fuel, a heavy fuel, or natural gas. So depending upon your location of operation, and depending upon the costs of the fuels at your location, you can utilize these different types of fuels. The second thing is that this technology, when in gas mode, it drastically reduces your exhaust emissions. So when you're in gas mode, right, the engine will operate and achieve a level of emissions that currently meets the IMO 3 levels that are out there today. So we'll do this without the use of any types of aftertreatment or any other types of exhaust reduction equipment. This also, when operating gas mode, your CO2 dramatically reduces as well too. So this definitely supports the CO2 reduction initiatives that are out there in the industry. And there's limited impact on the engine and exhaust system dimensions. So the engine itself, dimensionally, looks the same. There's a few features of some gas systems that are installed on the engine, but in virtually the same space that you have a normal liquid engine today, you can replace that with a dual fuel engine and not take up any more space in your installations. The engines are also set up to where if you have an existing liquid fueled engines, there's parts and kits that can be made available to just upgrade that engine into a dual fuel engine as well too. So the dual fuel system optimizes fuel consumption. Again, it's set for both a liquid mode and a natural gas or a gas mode as well. So again, the two key features, takeaways, are the operational flexibility to provide you that lower cost operation and reducing exhaust emissions. So you can see on this slide here, so here we've laid out the NOx standards according to the IMO regulations. So IMO 2 levels and IMO 3 levels. So you can see there's a dramatic reduction that's required in these regulations. And so the engines are set up to where as you're running in liquid mode, you certainly achieve your IMO 2 levels. And as you're running in a gas mode, you'll exceed the limits, or you'll exceed them in a good way. You'll be below the limits of the IMO 3 regulations. So again, the feature is when in gas mode, meeting the emissions without the use of aftertreatment. So safety is sometimes a concern when you're utilizing natural gas. And the engines have been developed according to the national regulations for gas-fueled ships. This is commonly known as the IGF code. And so that code is set up to provide safe operation of machinery when utilizing gas as a fuel. All right, and we've built in some safety features. So in case of a malfunction, again, of that natural gas system, the engine won't shut down. Instead, the fuel supply will be switched back to the liquid mode. So you've got really two sources of fuel on board that you can utilize to maintain power in your operation. There's leakage monitoring system throughout the gas system, so we detect if there's any types of gas leaks in the system, and we'll certainly alarm the operator that there is such a leak so that proper action can be taken. And then all the components, so as additional safety, of course, all the components are double walled. So that leak detection is usually in between those two walls of your piping system. So again, it remains contained within the engine. So as we move from safety features of the dual fuel engine, we'll transition to products we have that address safety concerns. So Caterpillar has a line of standard hazardous location products, anywhere from 20 kilowatts up to about 825 kilowatts of power. So these hazardous location products are complete power units from a radiator through a flywheel, and that can be used then again to drive whether it's pumps or generators, and we'll show you a few examples of what we've utilized these products for. And they'll meet various hazardous location requirements. That could be ATEX or NEC, Class 1, Division 2. And we'll utilize products from the, again, our C2.2, so a 2-liter engine, all the way up to a 32-liter engine in this range of products. And again, we also offer some gas engines that will be certified for Class 1 Division 2 wiring initiatives. So these standard hazardous location solutions, looking here at the smaller end of the product line, the 2 to 4 liter units. So this is anywhere from 20 kilowatts to 115 kilowatts of power. So this is a complete package that's built and tested at the factory. And for this product line here, we have ATEX only, not NEC Class 1 Division 2. And we also offer, there's varying emissions levels of products that are available in this range as well too. As we move up and look at products from probably about 150 kilowatts to 825 kilowatts, we'll utilize a 7 through a 32 liter engine. And again, these are complete units that are built at Caterpillar. And these products can utilize, be certified for ATEX and for Class 1 Division 2 applications. All right, so let me move in here before we end here to a couple examples how these can be utilized offshore. So the first example we have here is a temporary generator set for a Zone 2 area on board an offshore installation. So this is a generator set that's providing electrical power that meets the standards of ATEX or the IEC codes out there, the mechanical systems. And really what this does is it provides you the flexibility that as you need temporary power and you're looking for a place on your installation to put it, you can put this unit in a safe or a non-safe zone, because these are built for non-safe zones. So it kind of gives you that flexibility to place this power at various locations on your installation. The next example would be utilizing this for crane power. So sometimes a crane is in maybe right on the boundary between a safe and non-safe zone. So you can utilize this power pack to make sure that you're fully safe. You can see there the few standards that these types of installations utilize. And there may be some local regulations that we'll meet, and sometimes local regulations are at a lower level than maybe what this product can need. So sometimes it's a cost and safety trade-off that operators do have to go through in a process to say that they want to have this type of installation on board. And then finally, the last example we have is then these would be more permanent generator sets for offshore installations. So these are units that usually they're much larger. They'll go up to 1 or 2 megawatts of power or more. And they'll be at a permanent location on an offshore installation that is in a non-safe area. So therefore, we can provide those complete packages. And these are open or enclosed. Typically on the larger end, these are enclosed. So they'll utilize pressurized containers and so forth, but they'll be capable of operating in a non-safe area to meet, again, the ATEX or the Class 1 Division 2 regulations. So I want to thank you again for the opportunity to speak with you here today, to discuss here quickly just some things that Caterpillar are working on to address, again, the emissions regulations that are out there, the need to burn or the want to burn natural gas and utilize that as a fuel for your engines, and also the technology and the products that we're using to address the growing need of safety concerns and to have nice, efficient operations. Thank you.